All right, everybody, today we are looking at lesson 2.2, which is Introduction to Factoring. Now, up to this point, you have done factoring. You've done things like you've had 9 over 15, and you had to find the greatest common factor so that you could reduce this fraction, right? Depending on your teacher, you might have even done something like 9x to the 4th over 15x to the 3rd. You might have even used variables a little bit. What we are going to start introducing today is factoring polynomials, which is going to become a huge part of math class for the next couple of months. In fact, all the way up until Christmas, we are going to keep using some of these skills over and over again. So the first thing that you are going to look for when you need to factor a polynomial is a greatest common factor, which is something you've done before. Now it's a little bit different because you don't just have a 9 over 15. If you look at example 1 right here, you have a 6x to the 7th and a 15x to the 3rd. And you are looking for the greatest common factor so that you can factor it out. So let's just go through. There's a couple of steps here that we're going to go through, and we're going to jump right into example number 1. So step 1 is right here in your notes. You can find this among the coefficients first. Find the largest number that will divide evenly into all the coefficients. That's a lot of math language. The first thing that you do is look at the coefficients. You look at the numbers in front of each term. In this case, it's a 6 and a 15. And I am looking for the greatest common factor of 6 and 15, the largest number that goes into both of those, and that is a 3. Right? 3 goes into 6, 3 goes into 15. Second step is to look at the variables. And this says the degree of the variable in the greatest common factor is equal to the lowest degree among the polynomial terms. Look at my variables. I have an x to the 7th and an x to the 3rd. Now, because we're looking for greatest common factor, it's really easy to want to say that the x to the 7th is the greatest, and you're right, it is the biggest. But I want to look for the greatest common factor. And when I look at x to the 3rd, I don't have 7 x's. I only have 3 x's, right? I have an x to the 7th and an x cubed, which is an x times x times x times x times x times x times x. And over here, I only have 3 of them. So the greatest common factor is not the bigger number, it's the smaller one. It's the x to the 3rd power. That's the biggest number of x's I'm going to be able to factor out. So my greatest common factor becomes 3x cubed. All right, so that's step 1 and 2. Step 3 is I need to factor that out. Or in other words, this is kind of like distributing backwards, right? If I were to distribute, if I had something like 2x multiplied by 3x plus 7, and I take that 2x and I would times it by the 3x and times it by the 7, and I end up with 6x squared plus 14x. Well, now we are starting with the 16x squared plus 14x, and we are trying to go backwards. We are trying to undistribute whatever we can. So in this case, we want to undistribute 3x cubed. I want to pull that out and figure out what is left over in my parentheses, okay? So the way that I do that, I take my 6 and I divide it by 3, and that's just 2. I take my x to the 7th and I divide it by x to the 3rd. So if I have x to the 7th divided by x to the 3rd, those 3 cancel out, and I'm left over with x to the 4th. Then I take 15, and I divide it by 3. Well, that's 5. And x cubed divided by this x cubed, that just goes away, right? Those all cancel out, and I'm left with a 1. So when I factor out my greatest common factor, I end up with 3x cubed multiplied by 2x to the 4th plus 5. That would be my answer. Which seems backwards because, in fact, we just got done doing a lesson where you would distribute that 3x cubed, and now I'm telling you to undistribute it. You're going to have to do both. And being able to pull that greatest common factor out is going to make your life a lot easier over the next couple of weeks, because we're going to introduce this great big formula, and the smaller the numbers you're working with, the easier it is to use the formula. So you want to get good at factoring things out. So look at number 2. I want to factor out the greatest common factor again. So if I look at my numbers, 10 and 5, the largest thing that goes into a 10 and a 5 is a 5, right? That's the biggest thing that goes into both. And then, oops, I probably shouldn't put a parenthesis yet. Then I look at my variables. This one has an x to the 7th, but the 5 doesn't have a variable. So there's no x to factor out of the 5. So there's no x in my greatest common factor. So all that can come out is the 5. And I'm left with, on the inside, when I take 10 divided by 5, I get 2. And that x to the 7th hasn't gone anywhere. And 5 divided by 5 is 1. So this would be my answer after I factor out the greatest common factor. And if you ever aren't sure, all you have to do is redistribute and see if you did it right. Because if I take this 5 and times it in, I get 10x to the 7th. And if I times it by the 1, I get plus 5, which is where I started. So that's how I know I did it right. If I can distribute and get back to the start, then I did my problem correctly, okay? All right, those were easy examples. Let's get into something a little bit more fun. Number 3, 4a to the 5th times b plus 12a to the 3rd times b plus 22ab. It looks crazy. Let's start with the numbers. I've got a 4, a 12, and a 22. The biggest number that goes into all of those is the number 2. Now let's look. I can't look at my A's and my B's. I'm just going to look at my A's. I've got a to the 5th, a to the 3rd, and a. So the largest number of A's that I can pull out of everything is just 1a, because this one right here at the end only has 22 times a to the 1st. So I'm only going to be able to pull out 1a. And then if I look at my B's, there's a B, and a B. They all have an exponent of 1. So that's the biggest I'm going to be able to pull out, is just 1b. So when I factor this out, I go through and I divide everything by my factors. So this first term right here, 4 divided by 2 is 2. A to the 5th divided by a, when I pull that a out, I'm left with 4 a's. And when I pull out my b, b divided by b, that goes away. So that one's gone. All right, so now let's look at our second term. 12 divided by 2 is a positive 6. A to the 3rd divided by just 1a. If I pull 1a out, I only have 2 a's left, so a squared. And b divided by b makes that one go away. So then let's look at the last term. 22ab. 22 divided by 2 is 11. A divided by a is gone. B divided by b is gone. So my answer is just 11 for that part. So this would be my final answer when I factor out my greatest common factor. If you want to double check your work, go ahead and distribute the 2ab and see if you get back to where you started, okay? All right, now a great big one. Start with the coefficients, 50, 30, and 10. The largest thing that will come out is a 10. They all divide by 10. So now my p's, I've got a p to the 7th, a p to the 4th, and a p to the 3rd. So the largest number of p's I'm going to be able to pull out is that p to the 3rd. Again, I know it's weird. The largest is the smallest. And then let's go q's. Q to the 4th, q squared, q to the 4th. So my smallest q is q squared. And then I've got some r's. I've got r to the 1st, r to the 1st. But in this one, there are no r's. So that's like having r to the 0. So since that last one doesn't even have an r, there's no r to pull out. I can't do it. So I'm not going to factor out any r's because that last one doesn't have any. So when I factor this out, 50 divided by 10 is 5. P to the 7th divided by P to the 3rd is P to the 4th. Q to the 4th divided by Q squared is Q squared. And my R gets divided by nothing, so it stays there. Okay? Now 30 divided by 10 is 3. P to the 4th divided by P cubed is P to the 1. Q squared divided by Q squared goes away, right? Because that just becomes 1. And R divided by nothing leaves me with R. And then my last one, 10 divided by 10 is 1. I don't have to write the 1, but I will for now. P to the 3rd divided by P to the 3rd makes that go away, so that's also a 1. And then Q to the 4th divided by Q squared is Q squared. So that would be my final answer, other than I really don't need that 1, and it's going to drive me crazy to have it there. So this would be my factored form of that polynomial. Okay, now let me show you a special circumstance polynomial. If you ever have, this is called the difference of squares, and it's something, again, that's going to save you a lot of time and heartache later. Not just later this year, but later in your math classes in the future as well. If I have something that is a squared minus b squared, when I factor that, it comes out looking like this. A plus b times a minus b. So for example, over here on the right, x squared times x squared minus 36. Well, that's just x times x minus 6 times 6, right? So it's x squared minus 6 squared. So if I were to factor that, it would look like this, x plus 6, x minus 6. This second example, 4x squared, that's just 2x times 2x, which is 2x squared, right? 2x squared. Minus 7y squared is just 49y squared is 7 times 7 and y times y. So that's 7y squared. So my factored form looks like this, 2x plus 7y and 2x minus 7y. If you can recognize these, it will save you a lot of algebra and time on difficult problems as the year goes on. So look at number 5. K squared, well, that's just k times k. 100 is 10 times 10, and there's a minus sign in between. So my answer becomes k plus 10 and k minus 10. And I'm done. Number 6, 9x squared, well, that's just 3 times 3 and x times x. There's a minus, and then 25 is 5 times 5, right? So this is a difference of squares. It's 3x plus 5 times 3x minus 5. And I'm done. That fast. Number 7, a squared, that's just a times a. There's a minus sign. 121, that's 11 times 11, and b squared is b times b. So this is a difference of squares. It's a plus 11b and a minus 11b. That would be my answer. Now, if these had a plus sign, like number 8, if this was 16g squared plus 81h squared, this would not work. Please don't try to do it. It only works if it's a minus. That's why this is called difference of squares, because it has to be a minus. So 16 is 4 times 4. G squared is g times g. Minus 81 is 9 times 9. And h squared is h times h. So this one would be 4g plus 9h times 4g minus 9h. That would be my difference of squares. All right, so next class period, we are going to do some practice with both of these. We're going to just practice factoring out the greatest common factor, and I'm going to throw in some difference of square problems to see if you can recognize that formula when it is available.